We'll get started in just 1 minute here, folks. All right, cool. We are ready to begin. So, as usual, if you're in the Slack channel, feel free to bring any questions that you have in there regarding our material, or we'll accept outside material if it's within sort of the scope of what we cover. At my discretion, I may not want to cover a specific problem, but you're definitely welcome to ask and bring any Python questions that you may have to the table. So we're just going over Python stuff today, since that is sort of what we emphasize more in the TI. I want to make that sort of these study halls, at least for now, more oriented around the Python questions. Cool. So I'm not seeing any specific Python-related questions in the thread for today. Yet, at least. Maybe somebody's typing one, but I don't see that yet. So I'm just going to continue through the material where we left off. Last couple of study halls, I think just this week we started on, just on Monday, I think we started on accumulators, and we've been going through this in study halls this week. We covered the sort of high-level view, abstract of what an accumulator is, and talked about some how we think about accumulators as being sort of related to a type, integer and float accumulators, list accumulators, and Boolean flags. If you recall, Boolean flags is where you check some condition, and depending on something, you may switch some flag from false to true or true to false, depends. And this can be useful for doing something like if you encounter a scenario that will affect what you do in a future iteration, often just the next iteration, right? So you go through a loop and you find a situation that tells you, oh, okay, I have to do something in the next iteration of the loop. Then a Boolean flag can be really, really useful for that. You can set the flag to true, check if the flag is true, and then run some special code for that specific scenario where the flag from the last iteration is true, and then reset the flag to false. So that can be a good use case for the Boolean flag. And I just emphasize that because I know a number of people have had questions about Boolean flags and why they are useful, why they show up in this context. So yeah, so the accumulator pattern, I think I've emphasized this before. The accumulator pattern is really it's a central thing to understand in programming, in any sort of procedural programming. A lot of a lot of problems are oriented around simple accumulator patterns. So it's a very important thing to have a solid grasp on. Yeah. So let's just continue. This section is on parallel lists. So by the end of this lesson, we want you to be able to understand how to iterate over any number of lists simultaneously. So parallel lists are this idea of, like, if you have data in two different lists, and you can extend this idea to like two different dictionaries or tuples or strings or whatever. Let's just say we have lists, and let's do something like client names equals, let's say, Jess and John and Joanne and Jesse. And we can say client, what should we say? Client, let's just do something simple. Client ages equals, let me say, Jess will be 80, John will be 22, Joanne will be 24, Jesse will be 36. So what's happening here is, I think it's clear at this point, but we have data from one list that corresponds by index to data from the other list. So notice both of these lists have the same number of elements, and the information corresponds cross index, right? So index 0 holds corresponding information, holds the the name and the age respectively of one client, and index 1 holds the name and age respectively for that client, etc. So, okay. So let's say we want to iterate through these lists, and we want to just print the name. We'll do like an F string here. The name of the person is age, years old. So the name of each person is however old they are. So we can do something here. We can use, obviously we're going to need a for loop. So, and we're going to iterate through both of these lists at the same time. So I'm going to say for name and age, and I'm going to use a special function here called zip. Zip, you think about a zip like a zipper, like it takes two, you think about a zipper as like two lists of zipper tangs that, the zipper either joins together or splits apart, right? So zip sort of zips these two lists together so we can iterate through them all at once. So for name, age in zip, and since name is the first one, I'm gonna make client names the first thing that I pass to zip, and client ages the second thing that I pass to zip. And so what this is saying is, for the element from the first collection passed to zip, and the element from the second collection passed to zip. Oops, that has to be client ages. Excuse me, that's a little confusing. So for name and client names, and age and client ages, right? So for name, age in zip, client names and client ages, print out each name and each age. Name is age, years old. So let's run that, make sure it's going to do what I said it was going to do. So Jess is 80 years old, John is 22 years old, Joanne is 24 years old, Jesse is 36 years old. Cool. So zip is the tool. This is one of my favorite, most useful functions for iteration, right? So we've explored a number of things, of ways to like change this iterator section of your for loop. We've, I think the major ones here are, we're talking about zip today, but there's also enumerate and range, right? And these, to be clear, these do different things than these allow us to do different things than necessarily iterate through parallel lists. Although there is a way to do it with range, which we can talk about as well. But zip just makes it easy. The other cool thing about zip is, let's say, so this will work for 2 lists, but let's say I have another list, let's say client favorite colors. And this will be purple, blue, green, and orange. No, let's do red. Okay. I don't know why I find that funny. I'm going to go with it, though. I find it funny. Let me just kind of get some semblance of formatting going on here. Okay, I'm going to go for the whole thing. Okay. There we go. Okay. So now I can say, I can pass favorite color, client favorite colors to zip, and I can add, let's just say fav col. So for name, age, and favorite color, and zip client names, client ages, and client favorite colors. We can say print name is 8 years old. Their fave is favorite color is favcol. Cool. Jess is 80 years old. Their favorite color is purple. John is 22 years old. Their favorite color is blue. Joanne is 24 years old. Their favorite color is green. Jesse is 36 years old. Their favorite color is red. So we can do that. Zip will allow us to iterate through as many lists as we pass to it. So we can do it with 3 or 2 or 40, whatever. Although I don't know about, it seems like having 40 would be problematic in other ways. Cool. So we got a question here. Is name, age, name, comma, age one thing? Name, comma, age. There's a way of viewing the answer to this question as yes and a way of viewing it as no. But let's explore that a little bit. Let's think about what zip returns. Let's do this. I'm going to change the name of this because it's such a long variable name. I'm just going to call this fave colors. That's still extremely long. Let's just call this names and ages. I guess I could have just deleted clients everywhere because that's what I did. Cool. So name, age, and favorite color. So let's look at this really quick. This is a really good good question, and it's a good opportunity to explore something about zip, and also this applies to other things that we might iterate through as well. What I want to demonstrate here in answer to this question can also apply to enumerate, as well as dictionary.items, or actually any list of tuples or any collection of tuples, which is there's this interesting thing about them. So let's just say fourth thing in zip names, ages, and favorite colors, and let's see what thing is. Thing. Okay, so look at what we get printed out when we print out thing. So what zip is doing is it's iterating over all of these, where each group of items is the nth or the ith item from each collection, each list, passed to zip. Okay, so we passed these collections. In this case, they're all of equal length, which we're just going to lean into that for now. They're all of equal length. There's the question of like what happens if one is longer or one is shorter. We'll answer that in a second here, but we have these collections all of equal length with corresponding data in each index of the collection, and we're just going to iterate through them, and zip is going to give back a tuple of n elements of however many collections we passed elements, right? So in this case we passed 3 lists, so the tuple that it returns is going to have 3 elements each time we iterate through the list. So whenever you have something that you're iterating through that gives back every time, for each iteration, it's going to give back a tuple, which this is doing. You can pull that tuple apart into its constituent elements in the for loop, right? So the same thing is true. If you recall, enumerate, we usually do for idx, lm, or num, or whatever you want to call it. In enumerate, right? That's because enumerate returns a tuple where the first element in the tuple is the index, and the second element in the tuple is the element from the list that you're enumerating, right? If you do dictionary.items, you say for k comma v, or of course you can give these any names that you want. I'm just using sort of the canonically conventional names that they're often given. There's variations on this. You could call this key and val, or value, or whatever, in d.items, and when you're iterating through some dictionary. And that's because when you call .items on a dictionary in a for loop like this, you get a generator over the dictionary which is like a list, right? So you can think about it as it turns the dictionary into a list of tuples where the first element in each tuple is the key and the second element in the tuple is the value, and you can pull that apart in the for loop itself right here if we were doing dictionary.items, but we're not. We're doing zip, and this is name, ages, and favorite color. So if I just give it one name, I'm going to capture that whole tuple. If I call it A, B, and C, I'm going to capture each element from the lists passed in their respective order in each of these variables. So A is going to be the name. Oh, okay. Oh my gosh, why am I struggling with this? I'm like off today. It's been a funky day. It's Friday. I'm gonna blame it on Friday. Let's blame it on Friday. So name equals A, BC, oops, namey, what is wrong with me? Okay, age equals B, and fav equals C. Okay. Right, so this will allow me to pull this tuple that zip returns every iteration apart in the for loop itself, which is convenient. Alternatively, if we wanted to keep it as a tuple, which I don't know, I'm not sure that there's really ever a need to do, but you know, I could call it thing or group or top or something. I don't know. Let's call it top. I could say like name equals top sub 0. Let's do 1, 2, and then age, and then fav call, right? I could do this. I could do that, and then I would have access to each of these elements from the tuple being returned through each iteration under those names, and I could use them however I wanted. But being able to just deconstruct the tuple in the for loop head just saves me basically from having to do this, right? And I can have that in one line rather than 4 lines. So Python is nice that way. Let me know, to the person asking the question, if that's helpful. If anybody else also has that question or has other questions related to that, you know, let me know if that's helpful or if I'm being more confusing. But yeah, that's a good question. So I guess let me rein it in a little bit. The original question was, is name and age one thing? And kind of, because, you know, or in this context, is name, age, and favorite color one thing? And it's kind of because zip returns one thing. It returns a tuple, and we just break it apart into its constituent elements this way. So cool. Okay, looks like you got it. That's great. All right. Oh, it looks like we're going to cover enumerate in this as well. So understand how to iterate over multiple lists simultaneously. That's what's happening here. Use the enumerate function to iterate over lists, which we covered in a previous lesson, but it's worth mentioning again. Use zip function to iterate over multiple lists. Okay. Parallel iteration. Okay, we've got a question. Have a question about the second problem in the parallel lists challenge. Feel free to pop it in since your question is on this list challenge, or this challenge and learn that we happen to be on. I'm just going to continue through the lesson, and then when I get to the second challenge, I will look at your question before I offer a solve to it. But yeah, feel free to just put it in. Also supply, even though we're, you know, I know where it is because it's the lesson that I'm on, put a link in it just so that there will be a record of which problem we looked at. And if you want to supply any code that you have that you'd like me to examine or debug, you can do that as well, and I'll debug that. Or any other question, specific question that you might have about it. Cool. All right, so moving forward, parallel list iteration. Cool. So oftentimes you'll find that you need to iterate over many collections or sequences. Parallel iteration can be a helpful way to understand the behavior of mapping types, such as the dictionary type called dict, which you'll learn about in intermediate Python. Okay. it is ineffective and bad practice to use two separate for loops where one would suffice. Consider this example. So we don't want to do for num in list A, for num in list B. Yeah. This particular problem, we don't even need zip. We could use like extend or something, or just concatenate the lists together and iterate through them that way. But we could also use zip. They're giving us a different example using range, though. And this is worth mentioning. So as an alternative to the zip, let's look at the problem that I was, or this, this example that I was showing earlier. There's a different way to do this. We could say for I in range len, and all of these lists have the same length. So it doesn't matter which one I choose. So we'll say len names. Yeah. So for I in range len names, I can say name equals name sub I. Names sub I. And this will be ages. And say age. Fave color is fave colors. Okay. So I can use the index. I can iterate through the range equal to the index, the length of the index. Excuse me. Iterate through the indices by iterating through a range equal to the length, from 0 to the length of one of the lists. And I can use that index from range to index into the number from range to as an index to index into each list to find the element from that list, right? So this is sort of a more manual way of doing what we did with zip. And that's the example that they're showing here, right? So yeah, cool. So they're giving this example using range, and they're saying this code isn't much of an improvement, which I would say it is. It is quite an improvement, but we can do better with zip, which we already talked about. I showed them in the opposite order, which is fine. All right. So zip can take any number of lists and allow you to iterate over them simultaneously with ease. You can now even iterate over lists that aren't the same length, right? So zip automates the, it makes a decision about what to do if the lists are not the same length, right? So like I said earlier, what if, let's say we have another client, I'm doing all J names. I'm committed to it at this point. Juan. So let's say we have Juan in here. So we've got 4 ages, 4 favorite colors, and 5 names. Let's iterate through those collections like this and see what happens. Maybe we'll get an error. And this is a good time. Ask yourself, what assumption would you make about this? Just notice that you may make an assumption about what this is going to do. You may not, and that's fine. And notice what that assumption is. Or make a guess. And then we can look at this. We still get the same output as we did before, and that's because zip will iterate through whatever it will give back as many iterations as its shortest list that's given to it, right? So we have a list of length 5 and then 2 lists of length 4. If I have a list of length 2 here, oops, let's do this. Cap it off there so we can get that back. Then I'm only going to get 2 iterations because it's sort of the lowest common denominator thing, right? Like it can only give back elements for all 3 twice because the ages list is now only 2 elements long, so it's just going to stop when it reaches the end of one of those lists. Cool. And let's just say, let's say 1 is 42. And his favorite color is black. He's like he's the gothy sort, let's say. Which is cool. So if our lists are all now long enough to accommodate all the other elements in all the other lists, then we'll see the zip fulfilling all of the lists. Awesome. Okay. Hopefully that's clear. I'm trusting. I'm not seeing any questions, but hopefully that's clear. I'm trusting that people are synthesizing the information perfectly because my explanations are amazing, I guess. It's just what I'm going to go with since I don't see any questions. No. Yeah, do feel free to chime in if you've got anything. All right. So the person asking about the second problem in this section, feel free to post your question about that problem if you have a specific question now before we get to it. You don't have to wait for me to get to that challenge. If you wait for me to get to the challenge and I don't see your question, I'm just going to go through it. If that's what you want, then that's fine. But yeah, if you want me to take a specific question about the challenge before I go through it, then feel free to put that in now. Cool. So take special note of the syntax. So I'm sure what they're trying to emphasize here is this A, B syntax in zip list A and list B. So A and B sort of, what's the word? I always say deconstruct, but it's unpacking is the formal, what Learn refers to it as, I think what most people refer to it as. So deconstructs or unpacks that tuple. So the first part for A, B in this example is unpacking. Oh yeah, this is just what I said before. Cool. Parallel iteration with enumerate. So you can think about enumerate as a kind of parallel iteration unto itself. It's just sort of baked in sort of parallel iteration where, let's say we have my list equals and I want to iterate through the list, and in parallel to the list, I want the indices also for whatever reason. I can say for IDX, which is the index, and LM, which is the element. In this case, these are all numbers, so I'll call it num. in list. Of course, we want to enumerate because that's what I was talking about. E-N-U-M-E-R-A-T-E. Enumerate. And then, I don't know, let's just print the num to the IDX, I guess. We'll just do something with both of them, just because we have both of them. Cool. Yep. 161, and then 70,400 and oh no, 704,969. Cool. All right, so this is a sort of a kind of a listen to myself talk. This is a kind of parallel iteration as well. We can think about as that as a parallel iteration as well. Friday. Lols. Okay, so you've already seen the enumerate object used a few times throughout the previous materials. The enumerate is immensely helpful when you need to access both the value and the index of an element in a sequence or collection. Consider the case of evaluating a polynomial given a list of coefficients. Recall that a polynomial in standard form can be written as Pnx equals coefficient times x to the nth, or more succinctly as the summation from I equals 0 up to n, c sub I, coefficient 1, times x to the nth minus I, minus the value of the index. So sigmas are nice. When you see a sigma, you can always translate them into a for loop. So I don't have the c sub I tells me that I should have some list of coefficients. N is going to be the number of elements in that list. So let's just let's call this coef list. I'm just going to build this out real quick. So my coefficients list are going to be cool. And then we'll say x equals, I don't know, 4 or something. And we can do for I in range len coef list. Why did I do it that way? That's weird. Len coef list. Just put some spaces in there just for visual relief. Let's print that's c sub I. Now I called c coef list. Coef list sub I times x to the, yeah, that'll be fine, x to the n minus 1. And actually n is going to be the length here. N, let's do this, n equals this. It's the length of coef list. Let me make sure this is gonna actually evaluate correctly. Good. Yeah, let's actually just do this real quick. We'll just save this in a variable called res. Hopefully that's just a little clearer. And we'll say print res. This is the same as what I had when I was printing the whole thing. I just wanted to sort of break it out so it was a little clearer you know, where the parentheses for what I'm doing certain stuff versus the parentheses for the print. Ooh, 4096. That's a good one. That's evidently, that's 1 times 4 to the n minus 1, which will be, oh, excuse me, I said n minus 1, I meant n minus I. Cool. Makes way more sense. All right, cool. So this is sort of, you know, an example of, you know, processing a polynomial with a for loop. We were talking about enumerate, though. I wanted to show sort of the more raw conversion of this sigma formula with range. But we can also use enumerate. And we can say for IDX, or let's just keep it at I for I, and C for coefficient. Let's call it coef. So for I and coef, in enumerate coef list, coef times res equals coef times x to the nth minus I, and then we'll just print res, and we'll see. You're having trouble, okay, so we got a question here, having trouble grounding the coef list in a real world scenario. This example is just processing a polynomial, which the sort of the idea with coef list is each term in our polynomial is comprised of coefficient. I'm just going to call it coef because I don't think I can spell coefficient. Sorry. Coefficient times a variable to the power of some to the power of the order, which is essentially the index. So you have this order term. Often this is a term, and you know we could have n minus 1. It's related to the order. We often have often see a polynomial like 4x 4x cubed plus 9x squared plus, I'm so used to writing things in Python, you know, and like more programming notation than math notation. And then we could have plus 2x to the first, but since something to the first is itself, we'll just do that. And then plus then just we could just do some number 5. So these are decreasing 3, 2, 1, 0, right? So we're decreasing the order. So order is sort of it's related to an index, or it's sort of the inverse of an index in that case. So coef list is just a list of coefficients. And in this case, our variable, well, I should probably call this a const. variable is a constant. In this particular case, we're just using some value for x. And then our order is our idx, which I'm calling I in this particular case. So we get our order from enumerate via I, and we get our coef from the list of coefficients that I'm iterating through. Let me know if that's, I hope that's helpful. Yeah. Cool. So where the terms of the variable x are written in descending order, yes, of exponents. That's what I'm calling order up here, or I was calling order. And the exponents in of the leading term describe the degree of the polynomial. Meaning the degree is like, I mean, this example I gave would be a third degree polynomial. If I added another term, it would, with x to the fourth, then that would be a fourth degree polynomial. So the degree is the maximum exponent. It's the highest exponent in the polynomial. It's usually the leftmost, by convention it's just ordered from left to right that way. Well, by necessity, actually. Not just convention. All right, so as you see, the enumerate object is perfectly suited for this task, as both the index and the coefficients are used in the evaluation of the polynomial when given in the form of a list of its coefficients, right? So here we have an example. We're taking in a function, or we're writing a function. We're taking in coefs, which is presumably a list of coefficients, as I have demonstrated here, right? We're gonna have our accumulator res at equal to 0. In is just going to be the length of coefficients minus 1. This is equal to the degree of the polynomial. I forgot to add minus 1 there, so that's on me. So for the index and the value in enumerate coefs, res plus equals value times x to the power of n minus index. And that will give us a descending, right? So n is the order, and then index is it's the index. So since n is the length minus 1, the length minus the index is going to give us sort of a descending. It's like sort of the complement of the index, if you want to think about it that way. And it's going to give us descending numbers starting high and moving down, whereas the index is starting low and moving up. So yeah, and then we're just going to return the result. So yeah, why don't we just build that out? Let's just build that out. So let's have our coefs list. Let's print polynomial. Take in my coefs list. Okay. And then we'll def polynomial. Take in, so we'll call it coefs list, and some value for x as well. Okay, so I need to pass a value for x. We'll just do 4 again because that's what I had before. And then it's just an accumulator pattern. So we'll say res equals 0. Oops. N equals len coefs list, and whatever that length is, -1. And then we'll say for idx, idx and coef in enumerate coefs list res plus equals, what did I have? Coef times x to the, to the n minus idx. Oof. Return res. Guess it didn't matter. Good. Okay, cool. So this is the, the sum of that polynomial. You can do 2 or something, I don't know. Just playing around. Good. All right, moving on. Notice that n is defined as the length of the coefficient -1. This is because the last coefficient in the list is constant, or in other words, the exponent of x is 0. The enumerate function actually takes 2 arguments. Oh yeah, this is just a note on the enumerate function. With enumerate, we can decide where we want to start the index, right? We can start it at 3 if we wanted. In this case, we just want 1, or we just want index to start at 0, so we'll just leave that alone. All right. Oops, dang. The enumerate function exemplifies a powerful concept in programming. Each element in a sequence is uniquely associated with its index. Yeah, it's so handy having for loops and enumerate in the way that they are built in Python, because you don't have that in a lot of other languages. Mapping objects are special. Oh, map objects are a special. This is talking about map. Are we actually going to talk about map? No, I'm not going to read through that because we're not going to actually talk about map. Okay, cool. Oh, cool. This is actually giving an example of the tuple concept that I was talking about at the beginning of class. At the beginning of study hall, I mean. The idea that zip gives us, zip, enumerate, and dot items for dictionaries also give us this tuple of elements, and we can deconstruct that as well. Cool. On to the challenges. What will be the result of this summation? Okay, so we have nums A, nums B, for A, B, and nums A, B, res equals A times B. Okay, so yeah, so we have A and B. Let's just run this one step at a time. The first iteration, A is going to be 1, and B is going to be 2. So res plus equals A times B. A is 1, B is 2. 1 times 2 is 2. So res equals 2. And then the next iteration, we're going to have 3 and 4. A is 3, B is 4. 3 times 4 is 12. Rest's value is 2, so 2 plus 12 is 14. And then the next iteration, we're going to have 5 times 6, which will be 30. A is going to be 5, B is going to be 6. 5 times 6 is 30, plus 12 is 42. Oh, excuse me, 40. Wait, where did I go wrong? Oh, right. That previous iteration was 12 plus 2, which is 14. So 30 plus 14. Yeah, I'm just with it today. All right. Cool. All right, so here's the question somebody was wondering about. I don't see any particular questions, so I'm going to assume that we just want to move forward with a example of how I'd solve this. So write a function called enumSum. Let's just copy this out somewhere. Write a function called enumSum. Takes a list of numbers. Returns the sum of the numbers multiplied by their indices, incremented by 1. Okay, so do I increment it after I raise it to the power, or do I raise the index to the power, or the index plus 1 raised to the power? I'm going to imagine it's the latter, but fortunately we have an example here. So this says for this particular call, for enumSum of 2, 4, and 6, it looks like I'm going to get a sort of a breakdown here. This should give me index 0 plus 1 times 2 plus oops. Let's see if I can do this plus this. Okay. Gives us 1 times 2 plus 2 times 4 plus 3 times 6 gives us 28. Okay. We got this handy dandy little breakdown here. So index sub 0 plus 1 times 2 is equal to 1 times 2, which is 2. 2 times 4 is 12. Oh, this is just what I did previously, isn't it? No, God, 2 times 4 is 8. I was caught up with what I was doing previously. 3 times 6 is 18. Okay. So 2 plus 8 is 10, plus 18 is 28. Cool. And let me just consolidate this a little more. Okay, so this says, I'm going to add my own step here just so it's very clear what's going on. Okay. So this should be pretty straightforward. So now that I have a clear example of what I'm heading for, I know that I should end up with 28 for this. I can build accordingly. So we'll say def enumSum takes in a list for IDX num in list. Oops, of course you got to enumerate because that's what this whole thing is about. Enumerate the list. We want to add 1 to the index every time. So let's just start the index at 1. And then we'll say, what was it? We're returning a number. So returns the sum of the numbers. So let's call this res equals 0, res for result. Res plus equals, return the sum of the number multiplied by their corresponding index plus 1. So that'll be idx. Num times idx. And idx is plus 1 because I'm starting the indexing at 1 in enumerate. And then we'll return res. Let's see if that gives me 28. If it doesn't, I did something wrong. Which is, that's nice to know. That's what we want to know. All right, cool. Looks like that works. I'm going to assume it works. The person asking who had this question about this one, I hope this is helpful. Let me know. Not sure exactly what your question was, but yeah, hopefully that answers it. Cool, and it looks like this solution is the same. There's some comments and some different naming, but that's like the same. All right, looks like I have a solution for this one. It does not look like code I would write, though. Although perhaps it is. Implement the, here, I'll just do this so I can't see it. Implement the double sec sum function. All right, try that. Cool. Ah, nice. Even got that sigma in there. That's cool. Implement the double sec sum function. That's a heck of a name. Which takes 2 lists of positive integers and computes the summation. All right. So my list 1, my list 2, and let's just say, oops, equals a list and so this will take in my list 1, my list 2. Okay. Implement the function which takes, okay. So it takes 2 lists of positive integers and computes the summation according to this. Presumably we're returning that summation. Okay. Maybe these lists are a little too large. That's okay. Let's just start this definition and I'll kind of just get into it. Def this L list, list 1, list 2, and let's say res, this will be our summation, equals 0, and 4. Okay. Let's look at this. 1 minus, whoa, excuse me, that's not 1 minus, that's negative 1 to the power of k. Okay. So that'll be So this is k. It's using k as an iterator, but well, I'll be consistent. For k in I probably want to enumerate too. For k in num. Let's just do this. Num1, num2, and I'm gonna actually get a little funky with this one. So we can use enumerate and zip. Do I want to enumerate the zip, or do I want to zip the enumerate? I think I want to enumerate the zip. So let's zip first. We'll say zip. Doesn't really matter which one we write first. We'll zip list1 and zip list2, and we'll enumerate. Enumerate. Okay, so this is kind of funny because we have one generator that returns a tuple of 2 items inside of another generator that returns a tuple of 2 items. So before we even get into this, let's look at what this monster returns. Thing. Let's print the thing. I'm glad this problem's in here because this is a good example. I wasn't sure if they're going to cover it. Okay, so if we look, we have a tuple of an integer and a tuple, where the tuple has 2 integers, right? So we have this sort of double nesting going on, and we can unpack this. I'll show you how in a second here. The enumerate tuple has the indices. If you look at this left-hand column, these are the indices, 0, 1, 2, 3, 4. And then the tuple that it contains pairs of the numbers from list 1 and then the numbers from list 2. If we go down this middle column, 4, 3, 8, 9, 7, we can see those are the elements from my list 1, 4, 3, 8, 9, 7. And then the rightmost column, 2, 1, 6, 8, 9, those are the elements from my list 2, 2, 1, 6, 8, 9. Good. Okay, so the way that we can handle this is I can't quite just do k comma num1 comma num2 because the second element is actually a tuple, right? So for k and tup, I could do this and leave it there, but better yet, I can deconstruct it further. When you have a nested tuple that you're trying to deconstruct inside of a tuple that you're also deconstructing, or I mean unpacking, we'll put parentheses around the elements that represent the elements of the identifiers, num1 and num2, that represent the elements of the inner tuple, right? So if you look at the structure, 0 is our index. Let's just look at this first structure. 0 is our index. 4 is our element 1. 2 is our element 2, or our num1. 2 is our num2. And then since 4 and 2 are nested inside of the outer containing tuple, we'll put parentheses around that, and that'll give us access to each of these, like this. Looks a little funky, might seem a little confusing, but you will get used to it. So let's just verify that. Like this, k num1 and num2. Cool. 042, 131, 286, 398, 479. All right. So, I wasn't going to look at that solution. All right. So I'm computing this summation according to those rules. So let's see this. Where AK and BK refer to the kth elements in the two given lists. Okay, so that's just, I'm handling that by saying num1 and num2. Notice there's no upper bound on the summation. This just means sum over all of the elements. Assume that both lists will be the same length, and take note of the starting index of the summation. Okay. Where does it say the starting index of the summation is? Oh, 1, right? So we're going to start our enumeration at 1. That's why I like to add spaces in my function calls like this. Kind of makes it easier to see what's what, right? So I'm going to pass in 1 as the second argument in enumerate. Zip is actually the first argument in enumerate. So it's kind of funny. So we're going to start k at 1. So let's run that again. Make sure k is starting at 1. She should see 1 through 5. Good to go. Okay, so let's actually read this thing. So this will be, we want res plus equals, that'll be -1. We need it in parentheses like that. -1 to the k times a sub k plus b sub k, that's num1, num1 plus num2 for me over, I think I'm going to need to do this, over, second term is 1 plus a sub k, which is num1 for me. I'll make sure, I think this is what I want to do. Yes, it's got to be what I want to do. Num1 times num2. Whew. Okay. Print. Oh, no, I don't want to print. I want to return res. Okay, let's just get rid of this comment. Let's see what I get. I don't look like I have an example provided me for this one, but let's just hope it's right. I did already submit code for this one. Looks sort of thematically the same. Let's just check this out real quick. We'll just see if my solution works and we'll compare it to the previous one. Looks like I just did some different naming in the previous one. Yeah, looks good. This previous one, I called it sum underscore. I did A and B, which sort of has more parity with the original problem statement, which is kind of nice. And then, yeah, looks like the same, obviously the same formula here. Cool. All right. Let's see, I'll just comment that one out. Oops. I'll comment this one out. Save it like that. Good. We do have a question here about going through the probabilities questions, number 3. I don't mind taking those like offline in a one-on-one or a mentoring context, but generally I want to keep study halls more Python oriented for now. That may change in the future, but it's the reason is like that's where we notice people need to improve the most. That's for the TI and in the DSI in general. So I'm keeping it Python centric for the time being. Apologies for the inconvenience. I know a lot of people are having stats questions, but yeah, feel free to DM me that the person asking, and we can go over it one-on-one. Cool. So we're about at time. I know we got a bit of a late start today. I'm going to cut it off here. This is a good place to wrap up, sort of a natural ending. And we can start on the next section. Looks like break, continue, and pass coming up next. We'll be going over, I guess, more looping concepts, maybe getting into while loops for next time. So yeah, thanks for everybody who brought in a question. Appreciate the interactions. Apologies if there's any inconvenience about not wanting to take the stats questions at the moment. But yeah, I don't mind handling those offline as well. Anybody listening, feel free, if you're on Slack, DM me, hit me up if you want to do one-on-one. Things are kind of busy for the next couple of weeks before the deadline for interviewing for the February cohort. If you're interested in interviewing, the deadline is the 18th. We extended it. So just take note of that. January 18th, 2021. Just if anybody's watching this a later date, know when I'm referring to. So yeah, it's been fun. I enjoy doing this. I do want to make these as good as I can. Some people have recently brought up the resolution being low. This is a problem that I'm aware of. It's just right now it's due to a limitation of the machine that I'm streaming from. I'm upgrading my machine sometime in February, so apologies for the low resolution. I believe that will be ameliorated by next month, or within next month sometime. So hopefully they're still working for everybody and everybody's able to enjoy it. I certainly enjoy doing this. So yeah, I look forward to seeing all of you on Slack and interacting with all of you and doing future study halls. So until next time, have a good day. Bye-bye.